All right, this is a video to show an example of a trace function in Starter. So I already have a project open. I'm going to click on this icon here. Let's hover over it. It says accessible nodes. Click on that guy and it automatically starts. Now I happen to have everything already set up, so it found this, but let's just go real quick. I am using my USB interface to the front of a G120. Okay, so first click on that PGPC interface button, and we're going to use the device in this access point and navigate down here till you get to USB S7 USB. Okay. Click OK. Sometimes it takes a little while. And I'm going to click Update, basically refresh, do the search again, and I found this drive. Okay, so click on this box here and hit Accept to drag that into your project. Okay. And now, next step is to go online. Click this yellow button here, Connect to Target Device. And it'll say, what do you want to go online with? It's pretty much the only one in the selection here, so it doesn't really matter. Connect to assigned devices. And it says, hey, I don't know what hardware this is yet. So you can load that to the PG. And it says, I don't know what program is in it. Also, load to PG. If you don't know, PG is kind of German abbreviation for programming device, aka your PC. And we read a short book while this uploads. There we go. Okay. All right. Now I have my drive unit. You can expand that if needed to control unit to see everything in the drive. Just so you're aware, I set up this drive to have a external fault. Basically, I flip a switch and it faults the drive. If we go to the alarm screen down here, you can see this digital input 3 is going to go low. And I get a fault in my dialog here. Okay, so I'm going to return that to a high state. That goes green, and acknowledge faults with digital input 2. And everything's happy. Okay? Now what we're going to do when we're online with the drive, we can use this one of these green buttons up here. If I hover over it, you'll see it says device trace. That's what we want to do. And you'll get a screen that looks like this. So first thing we got to do is choose our signals. You may be interested in something like actual DC link voltage. Just, picking that out of the air. And it probably also helps to have some other things to go along with that. So something like speed actual value unsmoothed. And we'll also say current draw of the motor. Let's see. Absolute current actual value is what I prefer to use. We'll go with that. Okay, so now we've got these 3 signals here. And it says our maximum duration that we can record is 1.3 seconds, right? Or 1300 milliseconds. That's not quite long enough for what you might want, so you can increase this factor here. Now it depends on um, how many signals you have, all that kind of stuff. That will dictate how much of a time we can record here. Basically, there's a memory buffer built into the drive, and it's only so big. Okay, so we can just click this arrow to shove in the maximum duration to our actual record duration, or we can type in something useful to us. I'll say 4,000 milliseconds. Okay, that seems good. Next thing we need to do is set up the trigger. If this were set up as immediate, I would click this play button and it would immediately start recording the conditions of the drive for those 4 seconds and then spit it back out to my computer so I can read that. It's not what we want here. What we want is trigger on fault. Okay, so you can set a bunch of different types of triggers on this, but typically the most important one is a trigger at a fault because you're trying to troubleshoot some sort of condition that's happening irregularly or something, and that fault is probably your best thing to figure out what's going on. You can always try an instantaneous trace on certain things, and maybe that might show something that's symptomatic all the time, but doesn't necessarily cause a fault all the time. But typically, certain conditions only happen just before the fault. So that's what we're going to do. And very important, especially when using the fault trigger, is to have a good amount of pre-trigger, right? I've got a 4-second trace. In this case, I really don't care what happens after the fault occurs at all, but I'll leave a little bit of time there so we can see just what happens. So I'm going to say 3,800 milliseconds of pre-trigger. So it is going to record the 3.8 seconds before the fault and the other 200 milliseconds after the fault. Okay, and that's pretty much all I need. So once you do those, go ahead and hit trace, or excuse me, hit the play button, and that kind of downloads it to the VFD, and you can see trace 1 waiting for trigger. Okay. Do I have a little status screen? Diagnostics overview. You know what I'm going to do? I'm going to bring up our control panel real quick. I'm not going to use it, but I'm going to enable this monitor dialog just so we can kind of see what's happening in real time a bit. Okay, you can see output frequency, voltage, yada yada. Okay, so trigger my my drive. Right now I'm spinning at about 20 hertz. And what I'm going to do is I'm going to wiggle this knob around a bunch, my speed set point. You can see that kind of changing here on the fly. All right, so I'm going to, just so we don't have a completely steady state trace that's kind of boring and difficult to see what's going on, I'm going to wiggle this knob around and then I'm going to trigger that fault to occur, okay? And we'll see what happens. Okay. So the trace recorded and now it's loading. There we go. Okay. So actual speed unsmooth. You can see I'm sort of going between 1800 RPM ish, minimum of about 700 RPM. Our actual DC bus voltage. This is a 240 volt drive, so something in the ballpark of 300. I never go steady state here, but it's a pretty tight DC bus, right? Only about 328 to 335 ish, right? I don't have a lot of load, so or I don't have a lot of inertia on my motor, that is. And then you can see here absolute current varies a little bit, right? Again, I don't have a whole lot of inertia here, but just some info to look at and really hopefully get a good troubleshoot of what's going on. Oh, and actually, you know what? Here, we can see the DC bus right after the fault occurs. DC bus starts to increase. Basically, kind of telling me that the transformer feeding this little demo unit is a bit too small, but so that some of that time after the fault may be useful to you. And that's really it. That's all there is to it. You can also save these traces. All right, so I can save, select which traces. I think I only, sorry, measurements there. That's more useful. And you can save these, a TRC file, and send them to your friendly neighborhood drives app engineer so that he or she could help you out. And you can also save them with the project. Let's see. Oh, actually, no, you can't save them with the project. If I try to close this project now, I think it's going to prompt me, yes, should the curves be saved? If I say yes, it'll bring that up that same exact dialog as before to save those trace files. All right. And with that, happy troubleshooting.